Okay, let's talk about mean squared error. Mean squared error is one way that we can measure error. To recap on the definition of error from the knowledge resources, error is the amount of numerical difference between two pieces of data that are being compared. In the examples that I'm about to give and in AI, these two pieces are usually a predicted value and an actual value. The less error a model has, the more likely it is to give accurate predictions. For example, predicting a group of an object or predicting a value given other information. Let's start with an example. We'll be looking at how many items we will sell given the number of customers in the store. The goal is to try to be able to accurately predict the number of items sold given the number of customers. First, we start with actual values. Then, given the actual values, we can guess a line of best fit. Once you have the line of best fit, we can use this to create a new set of predicted values. The predicted values are calculated by using the line of best fit by inputting the input value of the actual value, in this case, X, which is the number of customers, and using the formula of the line of best fit to output a predicted Y, which is our predicted number of items sold. Now that we have the actual values and the predicted values, we can compare the actual and predicted values to get the mean squared error. What this actually means is that we're looking at the distance between the actual value and the predicted value, and using that to see how close we're able to get to the actual values. In this sense, we're calculating the accuracy of the line of best fit model. This distance is called the error. So how can we actually calculate the mean squared error into a numerical value? Before we do this, let's first gather our points and put them on a table. You can pause this video to understand how we translated these points into a table of values of actual values and predicted values, which we got again from our line of best fits. Now that we have these numbers written down, we can get into the formula of a mean squared error. The mean squared error is calculated by getting the difference between the predicted value and the actual value, squaring it, and adding these differences across each observation. Once we add all of these up, we can divide this by the number of observations that we have, marked by n. This seems really complicated, but we can actually break it down into small steps that give us this cool calculation. We'll be using this as an example to show how it works. First, we start with getting the difference between the predicted value and the actual value, just by using subtraction. So here we've calculated the difference. Once we do that, we can get the square root of the difference. If you're wondering why we calculate the square of the difference, you can check the questions that I put in the knowledge resources after this video. Once we get the square root of these differences, we can add them all up, which is signified by the summation. So adding up all the values over here to get 2.4. Finally, once we have all of that, we can divide this by the number of observations that we have, which in this case is 5 total observations. This gives us a mean squared error of 0.48. Great, so we've calculated a mean squared error for this line of best fit model for our prediction for how to calculate the number of items sold given the number of customers in the store. So what does this value mean? Is 0.48 a relatively good mean squared error or a bad mean squared error? To put this into perspective, let's look at if we had a different line of best fit for the same example. Let's say we had this line of best fit, which is much steeper. We can predict values just like we did before by marking new data points, and we would be able to calculate the mean squared error in the same way by getting the distance between the predicted value and the actual value. So I won't calculate the mean squared error, but think about if the mean squared error would be larger or less than the mean squared error that we had in our previous line of best fit, and what this tells us about which one gives better accuracy for predicting the number of items sold. Remember that the less error a model has, the more likely it is to give accurate predictions. So that was an example of how we can measure the mean squared error of a line of best fit model. And hopefully this explains a little bit more about how we use error to measure the success of a mathematical model in AI.